Hello and welcome to the Introduction to FHIR Search. My name is Gino Canessa, and yeah, there's a lot to cover, so we'll see how much we can get through. Minutia-wise, this deck should be in Whova. It was, because Firely's awesome, even though I was late turning it in. And then there's also a link there, aka.ms/ginoc/dex, where you can find this and all kinds of other presentations because I dump everything there. So if you're ever curious and can't go to sleep at night, you can click there and put yourself to sleep. Really quickly, the agenda, and I apologize, I like to move around, and I like when there's a screen here to point to, but there isn't, so I'll be pointing to these screens periodically. But just to go through what we'll talk about, we have the obligatory About Me slide, some of the differences from REST. I know a lot of people are new into FHIR and coming from a RESTful world. Quick talk about authorization and privacy, and then a bunch of search topics, context, methods, parameters, crossing resource boundaries, all kinds of fun stuff. And at the bottom there is just a link to the search specification. As I said, the obligatory About Me, I'm a software engineer at Microsoft. I work in research in a team called Health Futures. Specifically, our team does standards and interoperability. It's really fun. Our mission is to raise all boats, and Microsoft said, if you do that, someone else at Microsoft can figure out how to make a profit off it. So for us, we get to come to these things and talk openly and honestly, and not worry about the product side. So I've been doing FHIR since 2019, so relatively new compared to some of the old hands, but also 5 years isn't that new. Infrastructure, tooling, code gen, stuff like that. Since there are a lot of new people, I am also a FHIR Infrastructure Workgroup co-chair. I'm on the FHIR Management Group and the Technical Steering Committee, which is not nearly as interesting as it sounds. Before that, I spent a couple decades doing DICOM, and there's contact information for me. So disclaimers. I'm not a lawyer, but my wife is, so I tend to use these types of things. The search spec is really big. It covers a lot of use cases for a lot of things. And we are not going to cover everything in my already dwindling time. So this is kind of hopefully to get grounding, to understand where things are, how to look things up, and some of the things that are possible, and then the rest is going to be exercise for readers. So there we go. Jumping right in, if you're coming from REST, there's a few key differences. The first is that search does not return an array of resources. Typically, you have your product API, and you search for products, and you get an array of products back in the RESTful world. Here, we give you something called a bundle. It's a specific resource, and that is to capture a lot of metadata and give you a lot more of those things in a standard format instead of making everyone invent their own ways of doing that. There's a couple of special things I'll call out here in the next few slides, the self-link and paging. And then it's important to note that in a bundle, you can have entries, and those entries can be matches to your search. They can be included things that are related to those entries, or they can be outcomes, which are processing information, which again, we'll jump into here in a second. So the first thing is the self-link. This is in the bundle, and it looks a lot like the search you request. And it's interesting because a lot of people ignore it because it looks just like the search you request in a lot of cases. That said, it's not. First is that it's always formatted as GET. You can search via GET or POST. We'll talk about that in a second. And it doesn't actually have to be a valid search. It can just be a relative thing. The key is that it's the server telling you what it actually did. So you can imagine a search where you have 10 different filters that you're asking for, and the server actually could only process 9 of them. If we just failed the search because you had one that it couldn't do, what would you do? Well, go back, look for the 9 you support, and then resubmit the search with the 9 and do the additional filtering. Save you a step. We'll just give you the results of the 9, tell you that we only use 9, and then you can do the filtering. So it's really important that you go, anytime you do a search, check that self-link and understand what the server actually did. And this is just because, again, server can return more data, you can filter it yourself, and go from there. And oops, wrong direction, this direction. So we can see here, I have a couple of examples here, but this one, that's the wrong link. Self-link, this one was pretty boring because it didn't have any parameters. Let's find one that had a parameter. There we go. And so you can see that this is exactly the search I requested. I could probably make that bigger so you can actually read it. This is exactly the search I requested in this case, and that's perfect because then I know it counted everything that I was actually trying to filter on. Oops. The next one I want to talk about is the paging link. And this is the only way to know if there are additional results. There's an opaque link that you include in the bundle. And it's tough because especially when you're starting out and using test servers, it looks like things that you can play with. There's a bunch of HTTP parameters for count and offset and things like that. And a lot of servers expose that. But they don't have to, and you can't actually play with them in most servers. And that's because if we want to support things like a search cursor. In a search cursor, you can't change things. It's just the cursor. And so even though it could look like you can play with things to change the number of results you get or where you are on the page, I want to encourage you not to get into that habit because you will do that and then you'll find a server that it just doesn't work on. So the other important note here is servers are allowed to return fewer results per page. So even though you might ask for a page size of 10, you might get a set that has 9 or 5. Servers can do that type of thing if they're, for instance, you're asking for a very complicated query and they say, hey, it's getting too expensive, I'm gonna cut off you now and you can ask for the next page. And that's a very common thing in production. So you can't go by the size of matches or any of that kind of stuff because there are servers do that, can and do. So you always want to look at the next link. And so same type of thing here. You can see it's just another link in the bundle, next. And in this case, you can see it's just giving me essentially an encrypted something that I pass back. And so those are pretty standard. Oftentimes you'll get, do I have one of these open? Like Happy does this. You can see the next link here has this nice get pages with a GUID, and it has some offset of 20 and a count of 20. And this is great, and a lot of servers do this, especially the test servers, and it really helps you while you're developing things so that you can see what you're doing. But please don't rely on it because other servers will just return you some opaque blob. All right. A quick talk on authorization and privacy. I'm not going to dive into too much here, but essentially you can't trust what the server tells you, and that's because of how authorization and privacy work. If you ask a very specific question and the server says, hey, yeah, there's a result, but you're not allowed to see it, they've already given away a lot of information about the patient. So a lot of servers will just return an empty set. Or for instance, there's one vendor who in every search result says, there might be more results. If you think you need something, go through the break the glass elevation procedure. All these types of things happen. Your result set doesn't necessarily mean it's everything. So again, depending on what context you're working in, just do pay attention to that. Mostly, as far as the specification's concerned, it's out of scope. So those types of things are implementation details, and you need to talk through with the vendor of choice. So moving on to the actual search, we have this thing that I call a search context. And the context is just kind of where you're routing your search. And there's, I'll call them 3 defined kind of sets of places you can do this. The first is a system search. So that's when you say, hey, I'm at the root of the server and I want to search against everything that the server has. It's a great search for very specific things, and it's not a search that most servers want to allow otherwise, because it can be very expensive and very painful to do. So again, implementation support of it are optional. And even if the server does support it, they might not support it for you. If you're in the context of a patient app or things like that, it may not just be visible. That's fine. There's other ways to search. For instance, the resource search. So that's the second one there on the top right. This is the most common type of search. So when you look at a resource like a patient or an observation or a condition, these are the searches that are based on those. So you say, oh, I'm going to search across patients, I'm going to search against observations and put filters for a specific type or class or code or ID. You can do all that there. I will note, even though you are in one resource, you can link across different resources. And so we'll talk about that here later. But you can search and you can include things from other resources there. And the last one is the compartment searches. And I always struggle here because on paper, this looks like the holy grail of searches. And that's to say, for instance, in the patient compartment, I can give you an ID and just say, give me all the observations in this compartment for this one patient. And that's generally what we all want, especially for patient-facing apps. You can do the same thing with devices, and there's a bunch of these that are defined. The trick is that you mostly don't need to. Once you've authorized with a server, even if you ask for all patients, the server's not going to give you all the patients. They're going to give you the patients you have access to, which, if you're a patient app, is one patient, you. Same thing when you go and do observations. A server is not going to, after you've authorized as a particular patient, give you all observations for everybody. And so a lot of these compartment searches look great, but you don't actually need them. So support is hit or miss. When you're working in a specific context, in an IG or something like that you have arrangements, that's great. Otherwise, you're going to get most luck using the resource-based searches, and you can do everything you need to do there. All right, so search methods. The goal when defining FHIR Search is that we can use the same infrastructure across any type of search you want to do in FHIR. So most common are RESTful, and here we support both GET and POST. Servers have to at least answer you using GET or POST, but they are allowed to tell you, hey, I don't actually support that. So they can do the HTTP method not allowed. So really, there's certain contexts where you want GET. So for instance, when you're doing a provider directory, you want to be able to cache those things, and POSTs don't go through CDN's content delivery networks. POSTs don't do that very well. So in those cases, you want to have GET. And in other cases, you have very complicated searches that exceed the normal HTTP length of your proxies and all these things. So you want to use POST. We define both, support both, mix and match to your heart's content. As a server and as a client, just make sure that you can use either. Luckily, they're pretty much the same. When you do a GET, everything's in HTTP query parameters. When you do a POST, you have X form URL encoded. It's the same data, and actually you're allowed to use query parameters on POST as well. So sometimes you'll have some things in a POST and some things in query parameter. That's allowed. Once you go inside a bundle context, whether you're talking about a batch, a transaction, a messaging, or anything, everything's a GET. And that's just because all the things that we talk about why you might need POST don't apply anymore, because you're already in a bundle. So you're already posting a bundle, you're already doing these things, there's no limit length on the string, there's no worry about security or caching, any of that kind of stuff. You're already in a bundle, and if you don't have that figured out, it's not going to help there. I should jump across quickly, and it's really hard to see on this screen here, but we can see, like in this one, I should have some GET and some POST in here somewhere. Oh, there you go. So like here's a GET formatted search. So I'm just going to the base URL, patient, and I'm looking for the family name of Abernathy 524. And then in a POST, I'm just going to the patient /_ search. Demos. And in this case, I'm posting to that. I'm posting URL form encoded data, and it's the exact same string that I was putting in the query parameters. So pretty straightforward there. So I've mentioned a couple times we have search parameters, and these are the inputs, the filters, the things that you actually want to search on. The tricky part is because we're doing this over, for instance, an HTTP GET, we have a string. That's all we have. And if you're looking at FHIR, you see there's a lot of very complicated types. Coded information, dates are always complicated, quantities that have units and values, all these different types of things. And so we have a search type system that we can use to map between them. Because we needed some way to say this string gets split up into a system code and display versus, hey, this is just a string. So along with that, we have a couple of things to try and reduce the burden of developing a bunch of different search parameters. So you can do things like prefixes and modifiers and all these different stuff. We'll get into more detail here in a second. There's also something called result parameters. And this is a point of confusion for a lot of people. There are things that look like search parameters, but aren't. And I have some examples there, but kind of the canonical example is sorting. right? Your sort isn't a search filter. It's just changing how the results are presented. And so we pass it through like a search parameter, but it's not actually a search parameter. We can't define it that way. So it changes how you do discovery, and it changes some of these different things. Jumping back to when you do the post, that's often, those types of things are often in the URL, even when you're doing the post on the filters, because you're sorting or your summary flag or asking for different formats, all those things don't really matter. And then, depending on time, we'll go through multiple values and escaping rules here. That chart is probably too small to read. If you look on Whova, you can zoom in and look at it yourself, and it is in the search spec, but I did want to just have it up because it's easier for me to talk through. So again, not the most useful slide, but apologies for that. Essentially, that is the list of types we have, and when you start looking at them, there's, for instance, one reference type. Well, in FHIR, we have several reference types, reference, canonical reference, things like that, but we don't care. When we're searching, we just need some way to say this is a reference. Same thing, we have a single token type. We have a bunch of different token types, you know, codable concepts, codings, codes, all these different things. Doesn't matter. For the search, we can just take that single token type and convert it into whatever the actual target type is. And so this is just setting up the rules between them. There are two special ones I do want to call out. The very top one is called composite, and that is for when you need to join and make these really complicated sets of multi-value searches, which we'll get into. And then the other one is special, which is anything that doesn't fit anywhere else. And so on the next slide, we have examples of some of these. And again, they're probably too small because the screens are so far, but we can see that we have things like there's a number for dose number equals 2. That's pretty straightforward. We have a value quantity that is 5.4 milligrams according to units of measure as the system. So we're saying there, you can see it gets a lot more complicated, and this describes that vertical pipe syntax and what order you put them in and all those things. We can talk about things like the composite one, component code value quantity. That one's kind of a mess. But we're saying in an observation, there should be some component that is LOINC code 8480-6, and we want that quantity to be less than 60. And so you can see that in a single string, we can convey a lot of information back and forth. And then I'll just call out a couple of specials here just because they're funny. Like one of them is location, and this is for like geofencing. So you have GPS coordinates and area specification where it has the number and unit. We don't have a special search type for that. We don't want one. It's a very kind of edge casey thing. And so you just have the search type of special, and you have to go read that search parameter to understand how to parse it. Another one is this underscore filter thing, and that is essentially, I want to give you some very complicated string using, I don't remember, I think it's Spark rules, and build out this string and you evaluate it. Again, some servers will support it, some won't, most won't, but we needed some way to pass that through, and so that's what specials are. I do want to make a special call out here, though, on precision and implicit ranges. And this is probably one of the trickiest things in the search spec, or at least one that people most frequently get wrong, including myself. I'm not going to exclude myself here at all. And this is for things that are dates, decimals, quantities, and things like that. To me, the easiest one to look at is date. You might want to search for observations that were in 2024. So you can just pass it 2024 as a date. And the server needs to expand that implicitly into the range of the first second of 2024 to just before the last second of 2024, inclusive there or exclusive of the first second of 2025. And same thing, you can build out when you start saying, yeah, I want things that are in January 2024-01, easy. The trick comes when you want to do something like, hey, I want something January through March, you know, Q1, or I want the 15th to the 15th. We don't have a way of saying that implicitly. So now you need to expand out into two different search parameters and add equality prefixes so that we know you're looking for greater than or equal to this and greater than less than or equal to that, and do all that kind of stuff. So the same thing is true when you do numbers. So there we have like 2.5 versus 2.50. the server is supposed to treat those differently and use whatever you passed as the precision when it's doing that search. So plus or minus, 0.5 on the next decimal in. And these are all described on the search page as well. But they are tricky. So one of the things I alluded to before are these prefixes. They're used on the same types, numbers, dates, and quantities. They could be useful on strings and other things, but there's actually no way to tell if they're there. If your string starts with GT, that's a valid string. If your number starts with GT, that's not a valid number. So here we can put these things in front and kind of modify how the search comparison is happening. I just put a couple of examples here because there are way too many to actually do, but they're straightforward. Less than, greater than, less than or equal to, greater than or equal to, starts after, ends before, approximately. All the normal things you would do in testing, you can do here. And so that's what I was saying before about the dates. You can do things like greater than 2024-01 or greater than or equal to 2024-01. And there's one of the gotcha points too. Greater than 2024-01 would be great after January of 24. So that means start in February. Greater than or equal to starts in January. And so you can see it's very easy to get those implicit ranges when you start putting some of these explicit things. It's really easy to get tripped up. So the best thing I can say there is test. Put some data in that you expect to be in and out of bounds, and you can just test it, and you can do that on any of the public servers. So I mentioned earlier, when you have a string, we can't put these prefixes on it. And so we have another syntax called modifiers. These things go on your search parameter, and they can change actually a whole lot more than just that. So for strings, some of the examples we use are the default search comparison for a string is case insensitive starts with. But maybe you want an exact match. Well, you can tell it :exact in your search parameter, and now we're doing exact matching on the string. You might want to be a contains instead of a starts with. There's a modifier for that. But then you can also build in some very fun things into modifiers. These all have to be defined in spec, but anyone can file a ticket if they think they need one. But you can have things like missing. So that way you're just checking to see if a value is present or not. So now you're not giving a specific value, you're just giving true, false to see if that element is present. You have a not. Again, these are restricted by type. So for a token, you can do a not, and then see, give me all the results that are not this value. We don't do that on things like strings and dates because that would be very painful to implement. So we always balance that between things like that. Jumping forward into search result parameters, I mentioned these earlier. So here's just a list of them. Again, they're on the search page because that's going to be hard to read there. Or if you pull it up on Whova, the PDF is there, and you can just zoom on your phone. But things like count, include results that we'll get to here in a second, sorting, if you want summaries versus full resources, all these types of things, they're not actually search parameters, but they're defined in the search spec, and they look like search parameters, and you put them in the same places you put search parameters, but they don't have definitions behind them. And so that's the key point there, is when we get to like discovery, looking at the capability statement to see what options a server supports, they can't appear there because they don't have definitions. And so that's something we're working on. We have a project to try and address those types of things. But for right now, essentially you just try it and figure out if it's there or not. The server will tell you in the self link if they were used or not. So with that, you can search for any one thing you want. And of course, in healthcare, everything that we want to search for can be described by a single parameter, and we don't ever have to worry about joining things. And that would be a fantastic world to live in if that were true. So again, we're going back to the RESTful HTTP URL thing. And so really all we can do is define the behavior for doing multiple parameters. And in this case, we said and. When you have multiple parameters, they're and joined together. The reason being, if you want or join things, you can issue two queries. If our default was and, or was or, there would be no way to express and. So even though it can be annoying at times that we don't have or for multiple parameters, we have some mitigations in place, and that's why we did it that way. Something else to note there, the joining is set-based. So this is something that gets a lot of people. And what we mean by that is when you're evaluating multiple terms, each term is evaluated individually, and then the results are joined together. So one of the examples here is if you're searching for Jane Doe, so a given name of Jane and a family name of Doe. If a patient has two names, and one of them is, what did I use? Jane someone and Anna Doe, that will match your search for Jane Doe, because there was a name that matched Jane, and there was a name that matched Doe. So we're looking at the sets of results. If you need to do an AND join across elements, that's where we come back to those composite search parameters. So I invented one here called full name, and has two parts, a given name and a family name, Jane Doe, with that $sign in between. And when you search for that, those are evaluated together. So we have these mitigations on ways to do these complicated things, but we always want to keep in mind what the default behavior is. Same type of thing, we can do OR joins, and with that is this comma syntax. So when you have Jane, comma, Anna, you're looking for anyone who has one, the other, or both given names. Jane and or Anna, right? It's an inclusive OR. And you can mix them. So you can do family name is Doe, and the given name is Jane or Anna. That's fine. It'll give you anyone who has any family name of Doe, and anyone who has any given name of Jane or Anna. Escaping rules, these are pretty straightforward. Essentially, we can't tell when you're doing your implementation, what your pipeline looks like, what your proxies look like, what you're, down to actually seeing a request. So URL encoding is just transparent. We treat things the same, whether they're URL encoded or not, because we don't know who is doing the encoding and decoding. So that means if you want to embed a $, a comma, or a vertical pipe in one of your searches, you have to use a backslash in order to escape it. So you can see the example there. Jane, backslash, comma, Anna is actually looking for the literal string Jane, comma, Anna. So it's pretty straightforward, but worth mentioning because sometimes people think, well, this one's a vertical pipe and this one is the URL encoded vertical pipe, but on the destination, you can't see that. So once it goes through HTTP, we have no idea. All right, so discovering support. This I've mentioned a couple of times. Every server has a capability statement. You can access at metadata. Oh, I'm terrible. I should remember. It's that /metadata, and the capability statement for the server. And within that capability statement, you will see an array, you see an array of REST endpoints it supports, and inside that array of REST endpoints, you see an array of resources. And inside that array of resources, each resource has a bunch of different information, including the search parameters it supports. In a perfect world, everyone does that, and it's always correct and current and up to date and scoped to your client's authorization that you've already done and all kinds of things. It's a little hit or miss. Again, we're aware of that, and the same thing we're talking about for fixing some of the search result parameters and things applies here to get better able to ask those questions. So we are working on that. That said, in general, we have regulation. And regulation is great for saying you have to support things. So we're in the US, so we can talk about US core easily. And in US core, for different resources, there are required sets of search parameters that servers have to support if they're certified EHR, et cetera, et cetera, et cetera. But those are very widely supported. Those are defined generally just in text. So if you go to the US core implementation guide, you can see that they describe them. And there's often additional restrictions like you can search for conditions, but you have to provide a patient ID. And that's fair. That's a fair restriction. So things like that. But all jurisdictions have these. And those are going to be the ones that you have the best bet with. All right, and then same thing as earlier. Luckily, everything we ever want is fully contained in a single resource, and we never have to worry about going across them. And again, that would be so much simpler, but it's not true. So the first part we have, this is called chaining and reverse chaining. And this is when you have a reference in your resource, you can kind of just chain through it. And that way you can evaluate parameters past those references. So, I chose diagnostic report here. The same thing is true as in observation. There's a search parameter called subject. And in this case, we're saying, I want the diagnostic reports where the subject's name is Peter. Perfectly valid search, very useful. Again, some of those things I was talking about, like needing to provide IDs and things like that, a lot of times they come into play here. When you want to go backwards, we have this special search parameter _has. And that's because we don't have any way of describing in a nice chain what that would look like. So in this case, we can say we're saying, start with a patient and return to me the patients that have an observation that the patient search parameter matches the patient, so that's calling back to the resource we had there, and just the search criteria in observation is the code that's 1234-5. Sounds very convoluted. There's a lot of text on this describing it in the search page, but essentially we're saying we started in one resource, we have to say what's the other resource we're starting from, how do we get back to the resource we want, and then what's the actual search criteria on that other resource. There's no better order that we could figure out, so as awkward as it feels, it's definitely the best we've figured out. I will mention a tip there at the bottom. The reverse chaining is much more expensive than chaining, right? Because when you're chaining, you're just following through things that are typically indexed, and you're going from one search to the next search, and servers can optimize that very well. When you're doing reverse chaining, it's another search. And so when you start doing these complicated things with has and all these different things, the server is essentially pausing the set of results it had, doing this other search, and then rejoining those results later. Your mileage will vary. Depending on the implementation, I've seen 2 orders of magnitude different for doing the same search forward or reverse direction. So in general, if you can do it in forward, you're much better off. If you can't, you might want to split it into 2 different searches because you're just going to be causing a lot of extra pain for both you and the server. The same thing's true for including. So we have include and rev include, same way we had chain and reverse chaining. And this is saying, I want the related resources. So a good example here, you're starting from an observation, and that's great, you're going to get a list of observations, but you really also want the patient records. So if we don't define something like this, you get your results, your set of observations back, and then you just hit the server asking, okay, now give me this patient, now give me this patient, now give me this patient. The server already had all that stuff in context, and so it's actually more efficient to just include it in the first search. So here, the first one is just saying, yes, give me observations, and include the relevant patient resources. So that goes back to the bundle. We were talking about that you have match entries, and you can have inclusions. And this is how you specify what's included. We have a reverse include. So this is essentially the same thing, but here we're starting with the patient. And we're saying, okay, give me the patient record, but also include any observations where the patient matches that patient. And again, you can do it either direction. I highly recommend the forward direction. The reverse direction is going to be much less performance than the forward direction. Just so you know, it is also server discretion on what they include. So servers might include all the resources, might not include all the resources. You might get cut off. Hopefully, a well-behaved server will tell you that in an outcome. Not all of them do. Program defensively. I don't know what else to say on that front. I just do it as a call out on the bottom because we start getting very deep into the weeds. But in include and in rev include, you can also iterate. And that's to say, like, we started on observation, we want to include the patients, and then we might want to include all of the related persons from that patient. But you can't get to there from the observation, so what you actually need to do is iterate the patient records, and then in those include the related persons. Again, very powerful feature. As you start expressing these things, someone was asking me about optimizing a query last week that had 15 include iterates in it going across different resources. And I said, break it up into multiple queries. That's the only thing I can tell you, is that's a very expensive set of queries. You're traversing 15 different resources, iterating across all these things. It's gonna be slow. I don't have any other way to say that. So in some of those cases, again, I'm a software developer, so we get in that elegant, oh, I can do the whole thing in one request. It's not always the best thing to do, so just beware of that. And I think we're getting close to time, so I'll just say and more. Again, the search spec is big. You can batch searches, transactions, named queries, contained resources, external references, what you do with missing data, all kinds of other fun stuff. And we have a few minutes for questions, and we have a microphone here. So I know it was a lot, and I apologize for talking at you for so long, but this room doesn't really do that interactive thing. So, questions, comments, concerns, requests? Oh, there you go.
Hi, I just wanted to ask, you mentioned that the search uses the end joint, like it joins the different, when you add parameters, and I just wanted to ask why.
Yes, so the why is coming back to if you want to, let's say we had, going back to our example of a given name and a family name. If I had or joining, I don't have any way of expressing that those are that query that has both as a requirement. And so if I want to or join those things, I can just do one request with the given name and one request with the family name and join them myself. And so since we only have in HTTP, we can only do essentially a list of parameters, we had to say there's one behavior for every parameter you see, and the and joining gives us that. It also gives us things like when you want date ranges, you can do greater than this date and less than this date. If you had an or, you wouldn't be able to specify those things. So that's why we chose and. Yeah, love it or hate it. Yeah. Oh, I didn't even realize we had a second mic. That's amazing. Oh.
Hi. I don't remember you covering about the handling, like lenient or strict handling of the search parameters.
Lenient or strict in which context?
For accept, so if you have an unsupported search parameter, it's strict, you're supposed to throw a...
So that is, yes, so that is an implementation detail. We don't actually define that behavior. In general, servers in the spec are, we'll say, should just return the results because you can filter as a client and you just look at the self-link and understand what was there. There is an exception, and that is when you have a modifier you don't understand. Because again, if we're doing something like when we're looking for those missing things, if the server doesn't know what you're asking, you might not have the correct results. So in general, if we say the search would return too many, we say you should return them and let the client figure it out. And then for things that would be dangerous to actually do it, we say, yeah, there you have to refuse it. A lot of servers do have this additional flag, things like lenient and strict, that you can do either as a configuration or as a header or different things like that to say, well, no, just tell me if you don't support it and you can refuse it. In the spec, we try to be very open to those types of implementer things that need to happen. And so that's why it's a should instead of a shall, is giving servers that flexibility to do those behaviors.
Is there like something in the capability statement that you can set that would say that the server only accepts only has strict implementation?
I would assume that someone has created an extension for that. I couldn't tell you off the top of my head, just because it is implementation specific, and to my knowledge isn't something that there's been a big push to standardize. one of the things I was mentioning earlier to get this more granularity on these things is something called feature. We're just changing the name, but it's essentially the ability to ask server about specific features. And so that kind of thing would have a natural home there to say, hey, do you support strict mode or lenient mode or things like that? If a server knows about it, they might answer. For the rest of it, you just need to kind of discover that as you're doing your integration work with that vendor, because it is just implementation specific. So, awesome. We have 2 minutes. Awesome. I can keep filling it. We have a lot more content I can go through and examples and demonstrations, but interactive is better. We're all here in person. Yes?
Hey, are there examples where you would prefer post over get on the searches? I could think of one, for instance. Limiting PHI in like server logs and such.
Yes.
Can you think
so there is a very lengthy set of discussions about that. And the reality is if your logs are exposing post data, you're logging wrong. And at the same time, people do. And so that was kind of the perennial argument. We don't refer to that in the spec because it's not technically true. It doesn't actually matter. Gets and posts are no more inherently or less inherently secure. So the examples we used in the spec are for get, things like doing the content delivery network when you want to use caching. And then for the post is when you exceed the URL length. So especially in some of these, like we had the examples that have units, so you're searching for quantities with units that have systems and codes and things like that. And when you start getting into very complicated things about saying like, patients who've had a condition specified by any one of these 5 LOINC codes or any of these SNOMED codes, and they've been prescribed medications that are according to these RX norm codes and all these things, you can quickly exceed what a lot of servers will allow going through. And so there, the post is much simpler to say, well, you just put it in post and now it's a body and you can use as much content as you want.
Cool. Thank you.
Yep. Awesome. We have time for one more if it's quick. I'm sorry? Filter? No, I'm not talking about filter. I can, unless anyone has anything else. I was hoping. So underscore filter is, as Brian there is handily asking, is something that's defined in search for very complicated searches that we don't want to standardize, essentially. I would say your mileage may vary on implementations, but there are very few implementations of it, so it's more the other way around. But you can express very complicated sets of joins and criteria across many different things and add all these different types of filters and groupings and all this different stuff. It's great as a special search parameter example. That's why I use it there, because it's essentially this long string that someone else has to parse and do something with. But yeah, it's challenging. If you need very custom search, one of the things listed here are named queries. And those are essentially operations that get fed into the search infrastructure. And so you can define a named query to say like patients with diabetes. And then you can go through and implement that in, as long as the server implements it, then you can just ask for it in one nice little parameter. And generally servers prefer that because they can optimize those things. So, yeah. And with that, I think we're at time because I see people walking out of another session. So thank you, and anything, please feel free to reach out.